Welcome you all. In this session we are going to discuss the thermal breakdown mechanism. After successful completion of the session, the student would able to explain the thermal breakdown process. Thermal breakdown. When an insulating material is subjected to an electric field, the material gets heated up due to conduction current and dielectric loss due to polarization. The conductivity of material increases with increase in temperature, and the conduction of instability is reached when the heat generated exceeds the heat dissipated by the material and the material breaks down. Here in this illustration you can see that E1, E2 and E3 are electric field intensity, and E3, that electric field intensity E3 is greater than E2 and E2 is greater than E1. So as the electric field intensity increases, here you can see as the electric field intensity increases, the heat gain get increased. So here the temperature T1 and T2 are the increase in temperature. So within a minimum time period, that maximum temperature is attained and the heat gain is very high, or the losses will be high. Various heating curves corresponds to different electric stress as a function of specimen temperature. Assuming that the temperature difference between the ambient and the specimen temperature is small, Newton's law of cooling is represented by the straight line. The test specimen is at thermal equilibrium corresponding to field E1 at temperature T1, as beyond the heat generated is less than the heat lost. Unstable equilibrium exists for a field E2 at a temperature T2. In order to attain basic equation for studying thermal breakdown, let us consider a small cube with a dielectric specimen with a side del x and differential side length is chosen as x del x, and the temperature difference across its face in the direction of heat flow. Assume here the flow is along x direction, that is why we have chosen as del x is del t. For a temperature del t and the side del x, the temperature gradient is given by Cv dt by dt. Capital T represents the temperature and small t represents with respect to time in watts. So here the expression, therefore the expression becomes Cv dt by dt plus k into d by dt of dt by dx, which is equal to sigma E square. Solution of the above equation will give us the time required to reach the critical temperature Tc, for which the thermal instability will reach and the dielectric will lose in the insulating properties. However, unfortunately, the equation can be solved in the presence of from Cv, k and sigma is all functions of temperature, and in fact sigma may also depend on intensity of electric field. Therefore, to obtain solution for the equation, we make certain practical assumptions and we consider two extreme solutions for its solution. Thank you.